The next module, module 2, is on the details that need to be shown on house plans. So that this is what we need to put on house plans in order to make sure that the timber that's going to be used on the job is able to do its job properly and is going to be fit for purpose. So it's telling us how we designate and specify the timber on the house plans in order to make sure that it's going to be fit for purpose in the completed house. Wind classification is where I'm starting. Here is a house that obviously has a problem. Wind classification is vital to the performance of any members in a building. It affects the member sizes, it affects the connections between the members, it affects the tie downs, it affects the bracing. Nearly everything that we put into the structure is affected by wind classification, and it needs to be very clearly shown on the plans. It is a foundation stone of our design of the structure. And just check that the classification looks okay. If you've got a building with a really great view over the ocean and the plan says N1, it's probably wrong. Okay? So that wind classification is important. How do we specify timber? We specify timber by its size and its grade primarily. The size and grade affect the way it's going to perform structurally. If it's not big enough, it's not going to do its job. If the grade isn't right, it may not do its job. They're the most important things, the size and the grade of the timber. If it's MGP timber, then we don't have to specify the species, but if it's an F-graded timber, we have to also specify the species because that's going to affect things like durability of the timber. We also have to specify treatment, and it can be done in a number of different ways. On the plans itself, it often calls up the size and grade of individual materials and their spacing and how they're going to be laid out. And it may be a note that says what the treatment requirements are for all of the structural timber in the building. So we need wind classification. We also need to understand the weight of the structure that it's going to be holding up. Roof members are going to be sized differently if they're supporting tiles or if they're supporting lightweight roof sheeting, so that the cladding materials are important in the design of the material. They need to be easily discernible off the plans. And finally, spans from the floor plans are going to be appropriate as well. If we're looking at roof layouts, so that if we're looking at roof systems, we need to know what the roof layout is going to be. So we need to understand the way the roof is going to hang together. We need to be able to trace a load path from the roof right of the way down into the walls and then into the ground, so that the roof layout is really important. The structural drawing is going to assist us in following that load path through. If you can't see what the load path is, then more detail needs to be shown on the drawing. Roof-mounted accessories may also be required for things like trusses. So if people are designing trusses, they need to know what is the truss holding up. What is the truss holding down in the event of high winds? So we may need to know any roof-mounted accessories as well. And here you can see some plans that show the location of even future roof-mounted accessories. If we're looking at prefabricated wall frames, we need the floor plan, window and door frame schedule. We need the bracing layout so that we know which walls are going to be bracing walls, and finally timber treatment. So bracing details. Bracing details have to be specified for both directions. When we're designing buildings, we don't know what the wind is going to be in the next year, let alone in the 50 years of the life of the building. So we have to design bracing walls to resist wind from any direction. And essentially that means bracing walls that resist winds perpendicular to the long face and winds perpendicular to the short face. So bracing walls are going to be laid out in both directions and have to be distributed relatively evenly throughout the building. Tie downs. So again, the structural drawings need to show what the tie downs are going to be so that the builder can get them in the right place, and later on when the building is being inspected, there is something to inspect it against. So we can look at the tie down schedule and say, yes, all of the tie downs are actually in place. A note that is sometimes put on drawings, all timber framing and bracing not shown or not specified must comply with AS 1684. That's a cover-all that says if we haven't specified it, it's got to actually comply with 1684. BAL, bushfire attack level requirements. So external timber may be affected by bushfire and it needs to resist appropriate bushfire attack levels. So just check the drawings to make sure that a BAL level is indicated, or if there is no BAL level, that the building actually isn't in a bushfire prone area. Okay, often changes happen. Can you believe that? That as a building is built, some stuff gets changed. Make sure the plans and specifications are updated and shown on the drawings. And we'll look at some particularly important plans later on.